Hey everybody, so I thought we'd do some resistor or equivalent resistor type problems that rely on a couple principles. One is how to find the equivalent resistance when you have resistors in series. So resistors in series are configured like this, where you have the same current going through resistors, and resistors in parallel. When you have resistors that are in parallel like that. And when you have resistors in series, the equivalent resistance is simply the sum of the resistors, or the resistances. And when you have resistors in parallel, the equivalent resistance is kind of tricky to calculate. 1 over that equivalent resistance is equal to the sum of the reciprocal of all the resistors that are in parallel. In practicality, or in practical analysis, we usually just do equivalent resistances of two parallel resistors at a time. So you don't really need to do all of the math for several resistors that are in parallel. Though if you have a calculator, I guess that should be pretty easy. But if you're doing it by hand, you just have to remember that the equivalent resistance for two resistors in parallel is just a product of the two resistances divided by the sum of the two resistances. So with that in mind, let's go ahead and take a look at our sample circuit here, or our sample network. And our problem that we want to solve is find the equivalent resistance of that network. There's our EQ. So first thing you want to do is try to see if you can find some resistors that are in series, or resistors in parallel, that we can easily solve the equivalent resistances for. So as we mentioned before, here we have two resistors in series. Right? We have the 1 ohm and the 5 ohm, and that's going to be an equivalent resistance of 6 ohms. So let's use a different color pen here. How about red? Red, okay. So these two resistors are in series, so that equivalent resistance is going to be 1 plus 5 ohms, so 6 ohms. Just something to note now before we rewrite the circuit. And here we have two resistors in parallel, so let's go ahead and solve for the equivalent resistance there. Like we said, you're going to multiply the two resistances, so 6 times 3 divided by the sum of them, which is 9. So you have 18 over 9, or 2 ohms. Okay, so let's go ahead and rewrite this now. So we have our 4 ohm resistor still there, and then we have our 2 ohm resistor here. So 4 ohms, 2 ohms, just so we don't lose them. And now we're going to replace these two resistors in parallel with an equivalent resistance, which we calculated to be 2 ohms. We still have our 8 ohm resistor here. And now we've calculated this equivalent resistance to be 6 ohms. Okay, so hopefully you can easily see that we have these two resistors in series. So we can just add those two up to have an equivalent resistance of 4 ohms. So if we were to find the equivalent resistance of that, 2 plus 2 equals 4 ohms, right here. So we're going to redraw this circuit one more time. And we'll do it down here where we have a little more space. Oops. Okay, we have our 4 ohm resistor, and then we're going to put our 4 ohm resistor here, which was the equivalent resistance of those two resistors in series. We have our 8 ohm resistor still, and we have our 6 ohm resistor. Okay, so now we see we have a couple resistors in parallel. We have these two, so we can find the equivalent resistance of these two guys. So remember, they're in parallel. So here's how we find the equivalent resistance. We multiply 3 or 4, oh, blue now, okay, 4 times 6 over the sum of them. So 6 plus 4, that's 24 over 10, which is 2.4 ohms. Oops, you can't see that very well. And then run out of space. Well, I guess you have to trust me. That's 2.4. I'll put it down over here. I know my symbols look kind of funky. So we can redraw this circuit one more time. Let's see, is there enough room at the bottom here for it? Yeah, sure, we can try to fit it in there. We can redraw it here. 4 ohms. And then we have the new equivalent resistor here of 2.4 ohms. And then we have our 8 ohms here. And take a look. Now we have all 3 of these resistors in series. And as we know, as we noted up top here, resistors in series, we just add them all up. So to find the equivalent resistor or resistance of this whole network, we're down to just these 3 components in series. So we're going to add these guys up. And where do you have more room? I'll put it over here. So the equivalent resistance is equal to 4 ohms plus our 2.4 ohms plus our 8 ohms equals 14.4 ohms. There we go. Here is the equivalent resistance of that network that we started out with in the beginning. Okay, hopefully that helps a little bit. It's good practice to solving for or reducing or simplifying resistor networks using both our equations for series in resistors in series and resistors in parallel. Good luck in any tests, exams, or fun hobbies you are doing with resistors, and I'll catch you next time.